Hi, Math 3 students. So today we are going to be going over how we add and subtract rational expressions. Now, if you recall, when you add and subtract fractions, you need to make sure that you have something called a common denominator, okay? So let's just kind of go back to middle school here and think about, like, if I told you you had to do 3/10 plus 2/5, okay? With fractions, you need to make sure that you get your bottom number, your denominator, to become the same. You do this by getting equivalent fractions. So what you need to do is you need to figure out, like, what's the least common denominator? What's the smallest thing that I can make these two things equal to, okay? Now, looking here, we've got a 3/10 and a 2/5, all right? So we have a 10 and a 5. For Alexa, stop. For these, what you need to do is you need.
Traffic around
Oh
your
my God,
location
Alexa,
looks good.
stop.
There are no incidents
Alexa,
reported.
stop. Sorry, I really don't want to restart this. So, I don't know why she does the traffic thing. She does it every morning, and I don't know how to get her to stop. So yeah. All right. So, for numbers, you need to find the least common multiple. One way to kind of figure that out is, like, okay, you could break them down into smaller factors and be like, oh, okay, well, 10 is equal to 2 times 5, all right? And 5, you can't really break 5 down. So we know that we can get that this first fraction has 2 times 5. The second fraction is just 5. So we can make our second fraction have the same denominator by multiplying it by what it's missing. And it's missing that 2, right? Because the first guy had a 5 and a 2. So with fractions, you can get equivalent values by multiplying the top and the bottom number by the same thing. So I'm going to multiply the top and the bottom by 2. So I end up with 4/10. And then this first fraction is still remains as 3/10. Now, when you do this, yes, this guy you could reduce, right? If you reduce them, you're going to get back to this. When you're going to get a common denominator, you're kind of doing like the opposite of reducing the fraction. But now that you have a common denominator, you can go ahead and add these fractions. What you do when you're adding fractions is you keep your denominator the same, and you just add the values on top. So we would get 7/10. All right. So that's what we're going to try and do here, but we're going to also add in x values. Or I should say other factors, really. So here we still have our 10 and our 5, right? So we know that 10 can be broken down into 2 times 5, and then we have our x cubed. Now the second fraction just has a 5. So if we look, this second fraction is missing a 2, and it's missing an x cubed. So what we can do is multiply the second fraction by 2x cubed over 2x cubed. All right. So when we do that, we get 1 times 2x cubed, which gives us 2x cubed. And on the bottom, we get 5 times 2x cubed, which is going to give us 10x cubed. All right. And then we didn't do anything to this first fraction, so he remains the same. Now at this point, you can see that we have our common denominator. So when you add and subtract fractions, you leave your denominator the same. So we end up with 10x cubed on the bottom, and then you add the values on top. Now it works the same as if I was asking you to add these without any denominators. And you're essentially, when there's x values involved, you're going to be combining like terms. Now if you look here, we don't got any like terms, so we just have 2x cubed plus 1 as our answer. All right, let's try another one. All right, if you look at this guy, this one we're doing a whole number with a fraction, okay? Now, the fraction here has y cubed on the bottom. This guy has nothing on the bottom. Now, any whole number, or anything really, can be turned into a fraction by putting a 1 underneath it. So, let's turn this guy into a fraction by adding a 1 underneath him, right? 1 over 1 is equal to 1. And he's missing a y cubed on the bottom. So we're going to multiply the top and the bottom by y cubed. And that is going to give us y cubed over y cubed. Now the second guy's already got that common denominator. So we end up with y cubed minus 1 all over y cubed. Remember, you keep your denominator the same. Now, one thing I want to point out, and you're going to see this, when you're doing subtraction, you have to make sure that you distribute the negative to everything in the denominator, or I'm sorry, everything in the numerator. In this case, there was only one term, so you know, distributing to one thing is pretty simple there. So we just got -1. All right, next one. So if we look here, this guy, we've got 4x cubed, and the second guy is x squared. All right, so this second guy is missing a 4, and it's missing an x, right? If I do x squared times 4x, I'm going to get the denominator of my first fraction, which is 4x cubed. So that's what we're going to go ahead and multiply the top and the bottom by. So 4x squared, no, wait, hold on, 4x, my bad. And then 4x. So we end up with 12x all over 4x cubed. So we've got our common denominator, and on top we just have 1 minus 12x. You also could write this as negative 12x plus 1 over 4x cubed. I don't care which one you do. One just is in standard form on the top, and the other one isn't. All right, let's go ahead and try this next one. Number 42. So on this first guy here, we've got a 25. That's a bigger number, right? So we know that 25 can be broken down into 5 times 5, okay? So that means that the second fraction is missing one of those 5s. So we're going to multiply him by the missing 5. And then he also doesn't have the x that the other guy has. So I'm going to multiply my second fraction by 5x over 5x. So we get 30x all over 25x, which gets us to the same denominator as our first fraction, which is 1 over 25x. And we get 1 minus 30x all over 25x. And if, like I said, you can also write this as negative 30x plus 1 all over 25x. Either one of these are totally acceptable answers. All right. Let's go try this one. So my second fraction here has a y in the denominator. So my first fraction also needs a y in the denominator. He isn't a fraction to begin with, so we're going to put a 1 underneath him, and we're going to multiply him by y over y. X times y is just xy, and then 1 times y is y. We do minus x all over, I don't know why I did equals. Minus x all over y. So we end up with xy minus x all over y as our answer. All right, let's do one more. Now again, this first guy isn't even a fraction yet, so we're going to turn him into one by putting a 1 underneath him. This next guy has a 4 and an x cubed, so we're going to multiply him by 4x cubed over 4x cubed. We end up with 12x to the 4th all over 4x cubed. And then we get minus 3 4x cubed. So we end up with 12x to the 4 minus 3 all over 4x cubed. And that would be our answer there.